Today we'll create a scatterplot in Microsoft Excel. Scatterplots are used when you have two numerical variables and want to examine a relationship between them. Each dot on a scatterplot is an individual sample or replicate and has its own x, y coordinates on the graph according to the values for the x variable and the y variable. Let's say we collected the widths and lengths of a series of leaves and we're curious how the leaf width and leaf length are related to each other. We could use a scatterplot to show that relationship, and we could plot a trend line that represents that relationship. To create our scatterplot, first select the data and columns that you wish to plot. Click Insert and then Scatter under the Charts category. Your graph should appear on the screen. Like the bar chart we already created, Excel has included things that you don't really need, like figure title, but they haven't included things we do need, like the access labels. So take a minute and go ahead and add those like you did in the last example. I also don't care for these vertical and horizontal guidelines they include on your graph, so I also delete those too. I think that's important because I don't want anything on the graph that's going to distract reader from the important stuff, which is the data itself. Now let's add a trend line to show the relationship between our two numerical variables. Click on Add Chart Element, then Trend Line, and Linear. We selected linear because we can tell by looking at the orientation of the dots that there's a straight line or a linear relationship between those two variables. And if the dots had exhibited a different pattern, we might instead select a trend line with a different shape, like a polynomial trend line. You can see many of those different options under More Trend Line Options and the Format Trend Line sidebar. In fact, let's access that sidebar so we can add our next important pieces of information, the equation for the trend line and the R-squared value. Click Add Chart Element, then Trend Line, and More Trend Line Options. And you'll see this sidebar over here. What we want is this icon looks like column charts. Click on that. Scroll down to the bottom and check the boxes for display equation on chart and display R-squared value on chart. You should see a text box appear on your graph with an equation for your line and then the R-squared value. Let's click on the box and let's move it to a place where it's not overlapping or interfering with our data or our trend line. So maybe down here in the corner. This equation you see is the same equation for lines that you've probably learned about in math. So that y equals mx plus b equation. So in our example, y equals the leaf length, x equals leaf width, m is the slope of the line, and b is the y-intercept. So that location, that y value rather, when x equals 0. So it would be leaf length equals about 5.38 times the corresponding leaf width minus 9.61. Thus, if we inputted a certain leaf width, we can predict what the leaf length should be. So this is a very powerful tool for prediction. The R-squared value is a measurement of the strength of the relationship between those two variables, ranging from R-squared equals 0 to basically there not being a relationship at all between x and y, to the maximum R-squared value, which is R-squared equals 1. This would indicate a perfect relationship between x and y. In our example, we have an R-squared of about 0.83, which is actually pretty strong for field biology. Hope it's been helpful. I'll see you next time.